Okay, this is the second question that I gave you on the AP problem handout. It was question number 5 from the 2000 exam. Part A is to show that if I take this original function and do implicit differentiation on it, that I'll get this for the derivative. So I'm going to assume you were able to get that part. That's using the product rule and implicit differentiation. For letter B, find all points on the curve whose x-coordinate is 1. And write an equation for the tangent line at each of these points. Okay, if the x-coordinate is 1, that means I'll take my original function, xy squared minus x cubed y equals 6, and I'll plug in x as 1. So that gives me y squared minus y equals 6. I can make that y squared minus y minus 6 equals 0. Factor that into y minus 3 times y plus 2 equals 0. So y is either equal to 3 or negative 2. So that was when x was 1. So I either have the point 1, 3, or I have the point 1, negative 2. At each of those points, I can figure out the slope. Okay, so I figure out the slope by plugging that ordered pair into that dy dx equation. So this first one, 1, 3, if I plug in 1 for x and 3 for y, 3 times 1 is 3, times 3 is 9, minus 9, it looks to me like I'm going to be getting 0 for that. If I plug in 1, negative 2, because I got that on the top, so I don't even really need to worry about the bottom. When I plug in 1, negative 2, I get 3 times 1 times negative 2 is negative 6, minus negative 2 squared is 4. So I believe I get negative 6 minus 4 over 2 times 1 is 2 times negative 2 is negative 4 minus 1 cubed. So negative 4 minus 1. So it looks like I get negative 10 over negative 5, or 2. Okay, so this line, the slope is 0. So y minus 3 equals 0 times x minus 1, which simplifies to y equals 3. And this one, y plus 2 equals 2 times x minus 1, and you can leave it like that. Okay, that's part C. Okay, B, sorry. Part C, find the x-coordinate of each point on the curve where the tangent line is vertical. Okay, so again, this is my slope expression. dy dx equals 3x squared y minus y squared, I'm having trouble reading that, sorry, over 2xy minus x cubed. If I want the tangent line to be vertical, it means I want the slope to be undefined, because that's the slope of a vertical line. Well, an undefined slope, if this expression is slope, this will be undefined if the denominator, 2xy minus x cubed, is equal to 0. That would make the slope undefined. Okay, so I need to solve that equation. Okay, if I factor out the greatest common factor, I have x times 2y minus x squared equals 0, which means either x is 0 or 2y minus x squared is equal to 0. Okay, if I solve this second one, I get 2y is equal to x squared, or y is equal to x squared over 2. So these are my two possible situations that could create the tangent line being vertical. What I need to do now is test each of these situations with the original equation. Okay, so remember, the original equation was xy squared minus x cubed y. I better write that down. Xy squared minus x cubed y equals 6. Let me make sure that's right. Yeah. So what I'm going to do is test each of these situations. Situation number 1 was when x was 0. But if I substitute into this original equation that x is 0, I get 0 minus 0 equals 6, which is not true. What that tells me is that x equals 0 is not a point on this curve. This particular curve does not pass through any points where x equals 0. So this is not possible. This can't be a location of a vertical tangent. Okay, the other possibility was that y equaled x squared over 2. So let's take and substitute that in for all the y's. So the equation will say x, and where I see y squared, I'll put x squared over 2 squared, minus x cubed times y, which is x squared over 2, equals 6. Let's see what happens with this. If I work this out, that's x to the 4th over 4. So times x gives me x to the 5th over 4. And this gives me x to the 5th over 2 equals 6. Okay, I'm going to multiply both sides of this equation by 8 to eliminate the fractions. If I do that, my equation now says 2x to the fifth minus 4x to the fifth equals 48. If I subtract, I get negative 2x to the fifth equals 48. Divide, I get x to the fifth equals negative 24. And so take the fifth root, x is the fifth root of negative 24. Well, that does exist. You can take a fifth root of a negative number. So that's a perfectly good value. Okay, now the question, if I read it one more time just to make sure I know what I'm doing, the question said find the x-coordinate of each point on the curve. So I don't need to find the y, all I have to do is find the x. So x equals 0 was no good. We found out why. But x equals the fifth root of negative 20 the fifth root of negative 24 is a fine answer. All right, so that's how you do part C. I hope that was helpful, and I do really suggest that you stop the video and try and redo the whole problem again on your own. And then after doing the problem again on your own, then watch the video again, see if everything makes sense, and maybe do that a couple times to really make sure that you get this idea down. Okay? All right. See ya in class next Monday.